Operations with functions. In these following examples, we're going to be dealing with two different functions, one that's named f and one that's named g. They both have an input of x. When I take f of x plus g of x, I can also rewrite that as f plus g of x. We're going to be adding the f function and the g function, and x is going to be our input. Another way to see f of x minus g of x would be f minus g of x. These are synonymous with one another. F of x times g of x, you've probably guessed it. Fg means multiplication of x. And then f of x divided by g of x, we can rewrite that as f of x over g of x. And we can further simplify it to be f over g of x. Now, this one, because we're dealing with a quotient, we have restrictions need to be considered because of the denominator. So we've got restrictions that need to be considered due to a denominator which cannot equal 0. Okay, so let's practice with this. If I have g minus f of 2, we're going to talk about numerical inputs. So all of these are going to be numerical inputs. This is a numerical input. Well, g minus f of 2 is the same thing as g of 2 minus f of 2. So we're going to go to the g function and we're going to put a 2 in its place. G of 2 is equal to 2 times 2 squared plus 5 times 2 minus 3. 2 squared is 4. 4 times 2 is 8 plus 10 minus 3. 18 minus 3, I believe, is 15 today. F of 2 is equal to 2 squared plus 3. 4 plus 3 is 7. So g of 2 minus f of 2 is the same thing as 15 minus 7, which is equal to 8. Beautiful, beautiful, beautiful. Okay, f minus g of 1. Now we're talking about the f function minus the g function, so f of 1 minus g of 1. And I'm going to use a different color so that there's not too much blue going on here. Let's use pink. Now I got to find the pink. There we go. So f of 1 is equal to 1 plus 3. 1 squared is 1. 1 plus 3 is 4. So 1 squared plus 3 is 4. And then g of 1 is 2 times 1 squared plus 5 times 1 minus 3. So 1 squared times 2 is 2 plus 5 is 7. 7 minus 3 is 4. We have 4 minus 4, which is 0. And now we have g over f of negative 3. Change the color one more time. Let's make it green. So that's the same thing as saying g of negative 3 over f of negative 3. And g of negative 3 is equal to 2 times 9, negative 3 squared is 9, plus 5 times negative 3 minus 3. So 18 minus 15 minus 3 is 0. Now, as long as f of negative 3 is not 0, then we are going to have a very nice answer. F of negative 3 is negative 3 squared, which is 9, plus 3, which is 12. So we've got g of negative 3 over f of negative 3 is 0 over 12, which is also 0. So there's some examples of using numerical inputs. let's move on to examples where we're going to have algebraic expressions as our answer. So D says f minus g of x. I'm going to have to rewrite these functions because I don't see them on this page, but we are going to use the same ones. F of x equals x squared plus 3, and g of x equals 2x squared plus 5x minus 3. We have f of x minus g of x. No numerical values to put in. So in place of f of x, I'm going to put x squared plus 3. And in place of g of x, I'm going to put 2x squared plus 5x minus 3. So f of x, x squared plus 3, minus not just part of g of x, but all of g of x. So we're going to use parentheses. 2x squared plus 5x minus 3. I'll distribute the negative. X squared plus 3 minus 2x squared minus 5x plus 3. X squared minus 2x squared is negative x squared minus 5x, and 3 plus 3 is 6. So we have an algebraic expression for our answer of f minus g of x. G times f of x, g times f of x means g of x times f of x. So we're going to take all of 2x squared plus 5x minus 3, and we're going to multiply it to x squared plus 3. Now you can do double distribution. You might have learned it that way. I like to use boxes, so I like to use what we call an array. So I've got 2x squared plus 5x minus 3. And then down the side I put x squared and positive 3. And then I take x squared times 2x squared is 2x to the 4th. X squared times 5x is 5x cubed. X squared times negative 3 is negative 3x squared. 3 times 2x squared is 6x squared. 3 times 5x is 15x. And 3 times negative 3 is negative 9. So our answer is 2x to the 4th plus 5x cubed, 6x squared minus 3x squared is positive 3x squared plus 15x minus 9. And I'm going to take my blue highlighter and I'm going to highlight that answer so that you can see it. And that is the answer in standard form. So if it asks you for an answer in standard form, you must multiply it out in descending order standard form. Okay, 2 more problems to go for this set of problems. The only difference here is that we need to make sure that if we have restrictions that we identify them. So when we're dividing f of x over g of x, and we substitute in x squared plus 3 over 2x squared plus 5x minus 3, we need to factor or solve for real values of x to restrict from the domain. Okay, so I think that that might be factorable. We've got 2x times x, and then we're going to have a positive 3 and a negative 1. I just feel like we've had this problem a couple of times, this 2x minus 1 times x plus 3. I almost remember dogs barking or something in the background when we had that happen, but sometimes my memory fails me. So we're going to set that equal to 0. And I'm getting x equals 1/2 is going to be a problem because when we put 1/2 in, we're going to get a big fat 0 in that denominator. And we're going to have the same big fat problem if we put a -3 in for x. So this is our answer. Remember, it just said what is f over g of x? Well, f over g of x is equal to x squared plus 3 over 2x minus 1 over x plus 3. X cannot equal 1/2 or -3. We need to make sure that we put that semicolon there and list any restrictions that are not allowed. Okay, what happens if we have the reciprocal? G of x over f of x. Will we have the same restrictions? Well, in the numerator, we're going to have 2x squared plus 5x minus 3. And in the denominator, we have x squared plus 3. Well, we know that the numerator is 2x minus 1 times x plus 3. But the denominator doesn't factor, it's still x squared plus 3. So g over f of x. Do I need to put a semicolon and restrict any values? Are there any values for x that will make the denominator 0? Well, because we're adding 3, the only way we could get 0 is if x squared were equal to -3. When will that happen? Never in the real world, because positive times positive is a positive and a negative times a negative is a positive. Any number squared will equal a positive, unless we're in the imaginary world, and we are never in the imaginary world when we're talking about functions. That's probably one of the most important things that you can try to remember, is that you can never have imaginary numbers, not at the level of math that we're talking about. We never have imaginary numbers when we're talking about functions. So before I stop, so that would be our final answer right there. That right there is our final answer with no restrictions. I'm even going to write that. No restrictions.